Okay, so here we start with the part number 5 for the audio slides that I promised you to upload. So in this part, we're going to talk about the other type of the casting, which is going to be the permanent mold casting. For the permanent mold casting, the basic permanent mold casting processes that we have in general are going to be used for the metal mold instead of the sand one, like what we have in the previous type of the expandable type, constructed of two sections or more designed for easy and precise opening and closing. The molds used for the casting going to have lower melting points alloy, commonly made of steel or the cast iron. So the mold is going to be made of steel or the cast iron, which is going to have a melting temperature much higher than, for example, the copper or the aluminum or the brass. The molds used for the casting steel must be made of the refractory materials due to the very high pouring temperatures for the steel. So the steps on the permanent mold casting process are going to be simply have the two halves opening. We are going to spray nozzle to clean them and add some oil, and then we're going to close the two parts in the part number 2 and the figure number 2, add the cores if they're going to be used. Then we're going to pour the metal, wait for it to solidify, then open the mold and take the part. So the advantage of the permanent mold casting is that the good dimensional control and the surface finishing. Also, the rapid solidification caused by the metal mold results in a finer grain structure, so the casting are going to be stronger. Remember that we're going to have some pressure to inject the molding, the materials inside the mold. Then we're going to eliminate the effects of the shrinkage. Disadvantage or the limitation are generally limited to the metals with the lower melting points. Simple part geometry is going to be compared to the casting made by the self casting because of the need to open the mold instead of destroy it. Also, the high cost of the mold. The first type is going to be the die casting, where I'm going to have a permanent mold casting process in which the molten metal is going to be injected. Okay, now that's not poured, it's going to be injected into the mold cavity under higher pressure. So the molds in this casting operation are going to be called the dies. That's where we get the name of the die casting. Use of the high pressure to force the metal into the die cavity is what distinguishes this from the other permanent mold of processes, where it's going to be poured the metal. So this is just an illustration for the process where you press the molten metal. It's going to be run through the gating system, fill all the cavity under higher pressure. This results in a stronger casting and better surface finishing because the mold itself or the die is going to be made by machining on metal. In addition to that, we're going to have the elimination for the shrinkage because we are going to force the materials, the molten materials, to fill the cavities under high pressure. The die casting have two different types of chambers. We have the die casting hot chamber machine and we have the die casting cold chamber machine. You can see that the difference between them are. In the hot chamber, you can see that the, let me use the laser. You can see that the die is going to be directly connected to the molten metal chamber. Okay, so we just inject it directly to it, direct contact between them, and then the chamber is going to be hot. In the case of the cold chamber, we're going to do the melting in different place. We're only going to inject it directly by using the injection unit. So we're not going to have a direct contact with the hot part or the furnace. So the hot die casting hot chamber machine, the metal is going to be melted in a container attached to the machine, and the piston is going to be used to inject the liquid metal under high pressure into the die. In the case of the cold chamber, the molten metal is going to be poured into the chamber from external melting container, and the piston is going to be used to inject the metal under high pressure into the die cavity. The advantages and limitations of the die casting process are: first, economical for large production quantities. Also, again, to achieve a good accuracy and service finishing, and thin sections are going to be possible. Rapid cooling means a smaller grain size and good strength in the casting we are going to achieve. The limitations are generally going to be limited to metals with low melting points, and the part geometry must allow for the removal from the die. The other type is going to be called the squeeze casting, and this will be something like mixing between the forging and the casting at the same time. Okay, casting and the forging at the same time. You can see that the system is going to be consist of two sides of the mold. It's going to have a cavity. We pour the molten metal into the mold, then we're going to squeeze the metal in the mold and maintain the pressure until it's going to be solidified, then we're going to eject it out. Very easy, right? So we're going to have upper and lower die parts, and we are going to squeeze the metal, molten metal in between. The mold halves close after the introduction of the molten metal, as we mentioned earlier, and then the less pressure and final surface details can be achieved from this procedure. We have the semi-solid metal casting. So remember that some of the alloys, as we mentioned, they can reach what we the stage between the solidus and liquidus. So it's going to be a mixture of solid and liquid, or what you call the slurry. So casting process with metal alloys at temperature between the liquidus and the solidus is going to be applied in the semi-solid metal casting. Thus, the alloy is a mixture of solid and molten metals during the casting is going to be used in a mesh state. To flow properly, the mixture must consist of solid metals globules in a liquid, and this achieved by the stirring of the mixture to prevent the denitrate formation. Once again, we are going to melt the alloy, and it's going to reach the state between the liquidus and solidus. And then we're going to pour it, inject it inside the die, and we're going to have the part to be solidified. Then we can use it out. The fourth type of the permanent mold procedure is going to be the centrifugal casting. From the name, is going to applying the centrifugal force. It's an ideal process for making a seamless pipes and cylindrical shapes. Well, we're going to come to the definition of the seam pipe and the seamless pipe when we're going to do the formation of the metal. By introducing the molten metal into a high-speed spinning mold, the sound metal will solidify into the cylindrical shape under high pressure due to the centrifugal force. Classified into three groups: the true centrifugal casting, semi-centrifugal casting, and the centrifuge casting. So let's start with the true centrifugal casting. The mold is going to have a cylindrical shape, hollow cylindrical shape or pipe shape. Start to spin over the rollers here. Now we're going to introduce the molten metal. It's going to start to build a thin layer on the wall of the mold due to the spinning operation and the centrifugal forces. Start to solidify layer after layer. Then we're going to have the shape of the pipe. Okay, so the molten metal is going to be poured into a rotating mold to produce a tubular part such as the pipes, tubes, and rings. Outside shapes of the casting can be round, octagonal, hexagonal, and extra, but the inside shape is going to be theoretically perfectly round due to the radially symmetric forces. This is a very simple example of that. Now, the characteristics of the centrifugal castings are: first, continuous solidification starting from the outside surface due to the chilling effect with the metal mold eliminates the shrinkage and the inclusion from the casting. Centrifugal force makes the cylindrical shape with an accurate consistency. No restriction, no stress-inducing factors during the solidification make the residual stresses minimum. Now, the other type is going to be the semi-centrifugal. In that case, the mold actually is not going to be permanent. We can use a permanent one, but in this method, the centrifugal force is going to be used to produce a solid casting instead of the hollow tubular shapes. The density of the metals in the final casting is going to be greater in the outer section than at the center of rotation. The process is used on a part in which the center of the casting is going to be machined away, such as the wheels and the pulleys. The centrifuge casting. Now, in that case, not the section in the middle is going to be the product, but the end is going to be connected to the ends and using the centrifuge force. So the mold is going to be designed with the part cavities located away from the axis of rotation. The molten metal will poured into a mold is going to be distributed to these cavities by the centrifugal force. Used for smaller parts, and the radial symmetry of the parts are not going to be required as in the other centrifugal casting methods. So that's it for the section number, the part number 5, and we get to continue with the part number 6, which is going to be the last one. Thank you very much for your attendance, and see you later.